Okay. March 25th, section 8.4, ellipses. Right now we have a test scheduled for Tuesday that's going to cover ellipses and hyperbolas. All right. Today we're going to talk about all the parts of an ellipse. And I'm gonna warn you right now, there's all kind of little letters and signs and all kinds of crazy stuff, but I don't want you to get caught up in all that. I want you to listen to what I'm saying and understand how we get these things. All right, what's the picture? What's this a picture of?
That's the sun rolling around the sun.
Axis. The Earth rotating around the sun. Notice the yellow arrows pointing to the center. It's called the plane of
elliptic symmetry.
Why do you think they have that word elliptic?
Because it's elliptical.
Because it is in the shape of an ellipse. What did I say?
Shape of ellipse.
Revolving, sorry. The sun is running around, no, the Earth is running around the sun, okay? That's one example of how ellipses are used. Now, we could go into many examples, but we have 50 minutes of jam-packed algebra fun right now.
How about 2 axes and 2 lessons?
Axes. No, that's plural for axes.
Axes.
It's not axes.
It's 2 axes.
It's plural for axes. Okay? Now, not 2 like hatchet axes. Like, anyway. All right.
How do you spell that? Never mind.
When
I thought it'd just be still axes.
we talked about parabolas.
This time I got it. 2 axes of symmetries.
When we talked about parabolas, we had an axis of symmetry. In an ellipse, it has 2 axes of symmetry. Now, if you notice, I have 2 ellipses drawn here. This first one, I would call it, personally, a horizontal ellipse, simply because it is longer horizontally than it is vertically. Whereas the one on the right could be called a vertical ellipse. All right? Now, I want you to notice that both of these share the common center of the what? The origin, 0, 0. In this one on the left, the horizontal ellipse, we have a major axis, which is the x-axis. Yet in the picture on the right, the major axis is the y-axis.
It's the longest of the ellipses.
The longest axis is the major axis. Very good. The shorter of the 2 axes would be called the minor axis. Now, this is very important because depending on the way this thing is situated is going to determine how we write the equation, and it's going to determine where we find certain values to help us write the equation. Okay, if you remember in a parabola, we had focus, where a focus was not actually on the parabola, but it was used to help us identify other points on the parabola. The same way here we have 2, and it's called foci, which would be the plural form of focus. To help highlight it better, in this case, these 2 dots would be the foci of this ellipse. Notice they sit on the major axis. Now when you take your ellipse and you set it on its side or stand it up, where the major axis is the y-axis, now where are the foci located? On the y-axis this time instead of the x-axis, because this time, which one's the major? The y-axis. And your foci are always found on your major axis. All right? So where you find the foci depends on how the thing is drawn. Now, this B, is that a point or is it a distance?
Distance.
It's the distance from what?
From AC, from the major axis.
Radius.
Oh, don't just shout words out.
From the major axis to
Well, I thought that may have been it.
outside of the
The center point to the outside of the
Thank you. It is the distance from the center to the end of the minor axis. B represents the distance from the center of the parabola to the end of the minor axis. So what is the relationship of B's measurement and the distance in the whole minor axis?
half of it.
It's half of it. Very good. I want everyone to turn around to a partner and I want you to tell them, seriously, not jokingly, but very seriously, what B represents in a ellipse.
B represents
It's half of the axis.
minor axis.
Half of which axis? The minor axis. I'm taking this very seriously. Matt, tell Jacques what B represents. Very good. All right. Shh.
Oh, minor axis.
Now look back up here. In this horizontal ellipse, the minor axis is here, right? The minor axis was the y-axis, and so the distance was where is it on the y-axis? When I take my ellipse and I make it vertical, now B is here. Why? Because the minor axis moved. But it's still the distance from the center to the end of the minor axis. All right? Now C represents the distance from the foci to the center.
So that's on the long one.
That's on the long one. That's on the major axis. C is the distance from the center to the foci, or the focus, one focus. All right? Now here, C is lying on a different axis, but that's okay because guess what? So is the focus. So, is B an actual point? B is the distance from the center to a what? To the end of the minor axis. C is the distance from the center to the foci. Now watch this. A represents the distance from the center
To the outside of
To the outside of the major axis.
to the outside of the major axis. Okay, now this is very important that y'all get these straight in your heads because we're going to be writing equations from pictures. We're going to be given information, and you have to make sure you understand what B, A, well, let me say it alphabetically. A, B, and C represent. All right? A is not a point.
So it represents the distance.
It's a distance.
It represents the distance from.
All of them are the distance from the center to something. Okay? A is the distance from the center to the outside of the major axis. B is the distance from the center to the edge of the minor axis. And C is the distance from the center to a focus. To the outside of the major axis.
So why do you have one going
Because this finishes off a right triangle.
outside?
And we have the Pythagorean theorem that we're going to be able to use to find one if we know the other two. Okay? All right. In this specific graph, y'all need to be drawing this, by the way. Everybody who's just sitting around chewing on your fingernails.
graph 2.
Okay. What I want to make sure you draw, don't worry so much about this. Okay, that's it. What about the rest? Let's pause this while you draw.